Hi, welcome to the State of the Union 2020. My name is Isabela Bagueiros, and I'm the Executive Director of the Tor Project. We are a nonprofit that maintains Tor. Our mission is to advance human rights and freedoms by creating and deploying free and open source anonymity and privacy technologies, supporting the unrestricted availability and use, and furthering the scientific and popular understanding. Right now, I would like to ask you to please share this stream link and invite your friends to watch it. The State of the Union is a compilation of updates from our different projects. Normally, we do this event at conference, but because of COVID-19, we decided to do it online as a live stream. Our program has two parts. First, you will hear from the Tor Project teams about the work that they have been doing in 2020, as well as highlights of what is coming in 2021. For the second part of the program, we have invited other projects who are part of the Tor community to present and share their updates. Before we start, I'd like to remind folks that this is a fundraising event. You can donate to Tor by going to donate.torproject.org. You can become a monthly donor and receive a special Defenders of Privacy badge. Or if you donate more than $1,000, you will join our Champions of Privacy. where you will be invited to private webinars with demos from our teams and other interesting topics. You can also donate using cryptocurrency. And for State of the Onion, we are running a special promotion. If you donate $100 during the course of this live stream, only during this live stream, you will receive a special poster created by the artist Molly Crapibel explaining how Tor works and a t-shirt from this year campaign. Remember, right now, for every donation Tor gets, it will be matched by friends of Tor. That means your donation will make double the impact. I also would like to send a big thank you to all relay operators and all volunteers that contribute to Tor. Your contribution is extremely important, and there wouldn't be a Tor without you. So a big thank you from the Tor Project. Now, let's get this party started. Our first speaker is Gustavo Gus, who leads our community team. Please welcome Gus.
Hi, my name is Gus, and I work at the community team in the Tor Project. I'm going to speak about the work that we did this year and also what we are planning for 2021. This year, we released a new portal, the community portal, where contributors can learn how to be part of our community, how to run a Tor relay, how to run a Tor bridge, how to localize our tools and websites, how to run user research and collect user feedback, how to set up an owner service, and also how to organize Tor trainings. So since 2018, we have been working with human rights defenders in the Global South, delivering Tor trainings and building a more diverse Tor community. But in 2020, we were all affected by the coronavirus pandemic. We learned from our partners and our friends working in the field that how they were fighting against surveillance, pandemic, and censorship in their countries. At this moment, with the rise of surveillance and surveillance capitalism, Tor and privacy is more necessary than ever. We need to reach out people where they are, so Tor trainings, localization, documentation are very important at this moment. That's why we organized some online events, the localization hackathon, to translate and localize our websites. And a little bit before the pandemic, we also had the documentation hackathon to fix and update our documentation. We also did another campaign, new campaign called More Honest Por Favor campaign. Basically, we reach out to multiple organizations and help them to deploy this new feature called onion location. You can see onion location when you open a website with your Tor browser, like, for example, New York Times, and you can see a purple pill on the address bar. So some metrics for our work this year, on user support, we did over 800 we answer over 800 support by email. We reach out to our community in the Global South, in Brazil, Colombia, Mexico, Kenya, Uganda, Hong Kong, Tanzania, India, Indonesia, Ivory Coast, China. During the More Honest Por Favor campaign, we had over 60 websites that deployed onion location. And during the Tor localization hackathon, we had 28 contributors, 20 languages translated, 45,000 words translated during one weekend. So thank you, Erin, and the Localization Lab folks. This event was co-organized by them and was amazing to have your help here. And we also had 3 outreach interns and 1 fellow from the Berta Foundation helping us. What is coming next? We are going to release Onion Services Operator documentation. We are going to continue our work with digital security trainings in the Global South, and we are going to have a Tor trainings online meetup. And we are going to continue to work on online hackathons and campaigns, because this is how we are going to build the community and get in touch with people in our community. So thank you a lot. Obrigado. And the next person is my friend Matt. Thank you.
Hi, everyone. My name's Matt. I am a Tor browser developer, and I've been leading the Tor browser development and team for just over the last year. And boy, we have had an exciting year. So I'm just going to briefly talk about what we've done over the last year and what we're looking forward to in the next year. And so this past year in 2020, it was divided into two parts. The first part was related to Onion services and Onion service usability in Tor browser, and that included adding more a user interface for Onion authentication, which I'll show later. We added Onion location, which Gus just referred to, Onion errors, and Onion names. The second half of the year was really focused on transitioning Tor browser from an old version of Firefox onto a new one. And the reasoning for this is that historically Tor browser is based on the extended support release of Tor browser. And so the previous version was Firefox version 68, ESR, and we moved the desktop onto Firefox 78 ESR. And the reason for using the ESR is that it provides a stable foundation upon which we can build Tor browser enhancements and functionality. Unfortunately, on mobile, for Android specifically, the version of Firefox that Mozilla is providing is not a extended support release. So we're basically we were required to move from a very stable ESR version onto a rapidly changing Firefox version. And so this has been a challenge for us, and we've learned a lot over the last four to 5 months as we've developed this. But because we are really becoming a mobile-first development team and organization, we've been learning how to safely move from one version of Firefox to the next every single month. So this means that Android is actually based on, at this point, Firefox 83 as of tomorrow, whereas desktop is still based on Firefox 78. And so what does this mean? Well, it means that we are still developing one of the best privacy browsers available, privacy-focused, security-enhanced. And that is something that we truly are, that is our goal, and it is what we continue to work towards. And so from the first half of the year, the Onion authentication, we added this prompt, which allows Onion services to require authentication before a user is able to connect to it. And previously, users had to edit a configuration file in order to access sites like this, and now Tor browser automatically prompts for it. And that should just make using Onion services easier, which is obviously one of our goals. And for Onion location, which Gus referred to and talked about earlier with the More Onions Por Favor campaign, this allows websites on their domain name, like ProPublica.org, they're able to advertise to users that there is an Onion service available. And so users can optionally choose to visit that site, the Onion site, instead of the domain, the DNS domain. We also introduced Onion names, which we partnered with Freedom of the Press Foundation, and secure drop instances are now able to have these more human, meaningful, and memorable names like The Intercept. And this is instead of needing to remember or compare the long Onion address, like a version 3, which is 50-something characters. And so now you can just type in theintercept.securedrop.tor.onion, and that will automatically go to the Intercept's secure drop. And we introduced Onion errors, which are, they should give you a more obvious understanding of why an Onion address is not working. Either it's on your side or it's on the Onion services side, but now you should have some indication as to why you weren't able to reach it. But that was all desktop. What about Android? Well, as I mentioned earlier, we rebuilt the Android app on top of a new version of Firefox. And so, yeah, it's amazing. And this was quite a lot of work, and we are very happy about what we've accomplished here. And so with that, we are now fully supported on all of the platforms, Windows, Mac OS, Linux, and Android. And quickly coming up next, we have a lot of more exciting developments, like we're going to transition desktop from the ESR version onto the rapid release. So we're not maintaining two separate versions of Tor browser effectively. And we have a lot of exciting censorship circumvention improvements. And we're just looking forward to enhancing and continuing to provide privacy online. And with that, I am very happy to introduce Antonella to talk about usability.
Thank you. Hello. During this 2020 pandemic, we still got a few exciting achievements I would like to highlight today from the Tor user experience and design team. The huge work we have been doing around organizing our main website portals is evolving. In March, we launched community.torproject.org, the central resource for the Tor community. Community.torproject.org/user research currently hosts all our open documentation about Tor's user research program, guidelines for community members to run open research with the communities, and our Tor personas tool, an archetype with intentions and needs of our users. The UX team hosted 2 fellowships this year. Babatunde Okonushe joined us through the OTF Information Control Fellowship. Together, we published Censored Continent, where he shares his key findings about the examination of the use of internet circumvention tools in Nigeria, Cameroon, Uganda, and Zimbabwe. In a pre-pandemic world, he interviewed 33 people, including students, civil society members, people in business, and teachers, revealing how communities mobilizing themselves to defeat censorship. There's research of Narhira Lemos with the Berta Foundation about secure digital tools in the Amazonian region of Brazil with environmental human rights defenders. It's ongoing. She is researching the use of Tor browser in smart devices during extreme connectivity conditions. Practicing human-centered design methodologies, our ethical user research program, and our in-home fellow researchers informed the continuous work improvements in the browser for desktop and Android. We got 2 major Tor browser releases this year. In June, we released Tor browsers 9.5, focusing on improvement the understanding of Onion services for end users to enhance their adoption. We work on core usability issues for Onion site visitors. Using Onion location, websites can advertise their Onion service to users. It's the first time users can prioritize Onion traffic in their Tor browsers by opting in. We upgraded the network security layer by prioritizing Onions, and also improved the client layer security by exposing a usable interface to authenticate Onion sites. We improved our URL bar security indicators and our error pages, making them explicit on how secure contexts are and how recovery can be made. We know how vital are Onion services for keeping sources anonymous and safe. We collaborated with the Freedom of the Press Foundation and HTTPS Everywhere developers to deploy the first proof of concept of human memorable names for Onion services addresses. You can try it out typing the intercept.securedrop.onion in your Tor browser. During early October, we released Tor browser 10.0 with significant attention in the Tor browser for Android. We aim to reach feature parity with the browser desktop during 2021. With the current state of the world, privacy online is more than a human right. The Tor browser is a critical tool for this time of evolving democracies. By 2021, we are working together with the anti-censorship team to provide a better experience connected to Tor for users in censored networks. Censorship experiences different shapes. We are working on making the browser smart to detect censorship and harmful on providing bridges to connect to the Tor network. We hope this work improves the experience of the millions daily users who reach the open internet via Tor browser for desktop and Android every day. Thank you. And now David is going to talk about onion services improvements we accomplished in 2020.
Hi there. David is having some issues with his computer, so we're gonna move to George, who is a developer from the network team and is gonna be talking about onion servers as well and tokens. Go on, George. Welcome.
Hello, people. I'm George. I'm an onion services developer, and today I'm going to talk to you about memory. So memory is an amazing thing. It allows us to experience the world, remember the things we've been to, and remember the nice food we ate and the nice experiences we've had. And it's also particularly important in our digital life. However, in Tor, we don't have the concept of memory. The Tor network does not keep track of its client. It does not use cookies or anything. And every client that comes in and comes out, we forget about it. So Tor is memoryless, it's stateless. And this fact causes some issues, but is also part of how we get security. In this talk, I'm going to go through how we could potentially improve and introduce new features by introducing state in some way. So, for example, you might know that currently we cannot edit Wikipedia over Tor because Wikipedia is afraid of vandalism. And if in theory Tor could keep state about its clients, it could potentially try to distinguish or vouch for the good clients to Wikipedia so that Wikipedia gains more confidence that the good clients are going to be the ones that are editing. In a similar way, onion services are constantly getting attacked by denial of service attacks. And the attack works by the attacker hammering the service with traffic all the time. And we cannot stop this easily because there is no way to track how much traffic each client is pushing and if client is bad or good. But if Tor could remember, or the onion service could potentially keep state about the clients, it could potentially act before the attack happens. So I gave you two examples where the lack of Tor's memory is causing issues for us. And how could we improve here? For example, the rest of the world is keeping state using accounts. So you can have your Facebook account or your Signal account, but that's not very good for us because accounts are linkable and they link our activity to what we do. And this does not work for Tor. So, and a technology that we could use is that we could use anonymous tokens. Tokens is a part of the internet that is used in blockchains and also in other protocols like Cloudflare's Privacy Pass. And it's basically like a train ticket. So by having a train ticket, you can show that you've done some effort to acquire it, but it doesn't tie to your identity. So if you drop it on the floor and someone else picks it up, they cannot impersonate you or they don't know who you are. And a similar technique can be used in computers. So for example, in the denial of service scenario before, the Onion service could issue such tickets and give it to their clients, and the clients would then give it to the Onion service when they connect, and in this way they will get service before the attacker. So now, if we had this technique of tickets or tokens, how could you use it in other scenarios? So, for example, we could design a secure name system so that people can register names for their onions using those tickets, and we can finally have human memorable names for onion services. Or censored users right now need to acquire bridges by solving a CAPTCHA, and because CAPTCHA is not a hard thing to do, the attacker does it before them, and they manage to harvest all the bridges. But if we could use tokens, we could have a way to give bridges more intelligently. Or we could use tokens to incentivize the community to grow. So I hope I gave you some examples of how tokens can improve things and how we could use them in Tor. So that's it for me. And next is going to go David with our progress on Onion services. Thank you very much.
Hi, everyone. Thanks, George. I'm David. I'm part of the network team that maintains Tor. George is one of my colleagues on Onion services. I will present what happened this year in 2020. So the very first thing that happened, we decided to deprecate version 2. Which is the Onion services that have the small addresses. You can see it on the wall there. It's a big problem. It's a big mess. It's a bit of a dumpster issue because there are many problems put into one dumpster, and we are getting rid of it. So of course those issues includes cryptography. So RSA 124 is still an issue. It's I think one of the last thing that is being used in Tor. We have those addresses that are truncated SHA-1, and since I think last year SHA-1 has been shown to be very cheap and easy to break or collision. So that's the main reasons we're dumping Onion address version 2. So there is also this problem with Onion address version 2 that they are discoverable. So you just have to look in the network and you'll find almost all of them. So the version 3 that we introduced a few years ago have this property that you cannot discover Onion addresses if you sit long enough on the network. So this is also another big part of improving privacy, where if you have an Onion address with version 3, it's not discoverable. As V2, we're going to get rid of it. And unfortunately, this is a very fast approaching timeline. On July 15th, we're going to roll out stable versions that will remove version 2 address. So it's going to take a few months before the network adapts and rolls out to this new version. But please consider that by July 15th, there will be no more V2 support on the network. I encourage you to go to that address on the blog for the timeline. Now, there is a second very exciting thing that we added in Tor is called the metrics port. And the metrics port is a port that you open, and there's, of course, policy because it exposes a lot of information from Tor, so it has to be used carefully. But those metrics will allow you to do things like this, which is a very nice dashboard where you can track the connected clients, the request, the bandwidth, the reachability status, and much more we have planned for. We plan also to extend this metrics to relays and export a variety of different metrics. That allows us to, this is one of the example dashboard in Grafana. Another thing that happened this year is Onion Balance version 3. So Onion Balance version 2 was a very popular tool for load balancing. So you can spin many Tor backend to serve a single Onion address. And thanks to George's work, version 3 has been stable and done, and now it's totally usable. So again, see this URL for the documentation and how to deploy it. And if you have any questions, please ring us. Another thing that George in part covered in his presentation is we had a fair amount of problem with denial of service. Onion service I've been attacked quite a bit, various different onion addresses on the network, and we had to move quickly at the beginning of the year to try to fix the defense, to add defenses to the network. So we chose to put on defenses that protects the network rather than improve availability or reachability of the service. Because back in 2018, end of 2018, we had onion service denial of service that were pretty damaging to the network. So these are the options you can set up, and will create this denial of service defenses for your service. Now, the good thing about those services is that if there's an established circuit from a legit client to your service, even though it's under DDoS, this circuit will not crumble, which was the case before. So at least there is this thing where the service will still work, but might not be that reachable. This is the last thing that happened. Matt and Antonella covered it mostly, because those are user experience and UI things on the Tor browser side, but it's basically that through the control port we added client authorization, which allows us to have Tor browser integration. And we also have the SOX5 extended errors, which allows the Tor browser to give you more meaningful error messages. So that's what covers it into the Onion Service 2020 world, and the 2021 future was mostly covered by George in his previous talk. So thank you very much, everyone. And to that, I will pass it on to, I can't remember actually. I will pass it on to Mike for scalability. Thank you, everyone.
Okay, so I will be, Tor just embarked on a 2-year performance and scalability project that I'll be talking about. We started this in October. So to get started, though, I want to give some from our metrics to show what the Tor network and Tor performance currently looks like. Right here, we have a graph showing the total relay capacity. In the top line in green is the total relay capacity of the network. And the bottom line in purple is the actual usage or utilization of the Tor network. As you can see, the Tor network has been increasing. We've been adding relays continuously throughout this span from 2011 to 2020. We've had a couple of good events here. We had when Edward Snowden made his disclosures on the surveillance of the NSA, that actually encouraged quite a few people to show up and start running Tor relays. However, strangely, the number of people or the utilization of the Tor network didn't increase quite as much. You can see the slope of the purple line didn't go up quite as much as the amount of capacity we added. Similarly, when Trump became president and was inaugurated, well, we also had a denial of service attack and some attacks on the network, so it was a brief loss of capacity. But then after that, the rate of people running Tor relays and volunteer community was even more mobilized, seeing that pretty much anyone could take control of the surveillance apparatus that Snowden warned us about. And even more people started running even more Tor relays. But still, while the rate of usage of that relay capacity increased, it did not increase quite as much as the relays that were added. And if you can see in 2020, right here at the end of the graph, we're actually using less than half of the total capacity on the Tor network. You look at some more metrics graphs from, again, metrics.torproject.org. Here we have the download throughput, the download rate when downloading through a public internet server over the Tor network from 3 different measurement points. During Snowden's relay campaign, effective relaying campaign, performance did in fact increase. You see the throughput is increasing on all of our 3 measurement points up till about 2015. And then things sort of start to level off. The throughput sort of just remains constant from 2015 onward. And if you look at the situation today, we can see that it's still flat at that same throughput. And if you look closely at these graphs, on the left we have the public server, and on the right we have Onion service downloads. The Onion service, strangely, is half, the throughput is half of the exit throughput, even though exits are often scarce and there's not enough of them, and Onion services don't use exits. There's still almost exactly half from our measurement points. Additionally, our measurement points have some variation in performance. So there's quite a few strange things going on here on the Tor network that we're going to aim to fix. Despite a huge influx of Tor relays, Tor is still slow. The network capacity is at all-time high, but 50% of it is unused. Relay operators are coming to us saying they're trying to run fast Tor relays, but they're not. If they put like a gigabit at a relay up, they're not able to use all that throughput. There's just not enough Tor traffic seemingly, or the Tor clients are not able to utilize all of that. And client throughput has been flat since 2015. Clients just aren't getting faster, even though there is more capacity being added to the network. And Onion services are half as fast as exits. So we have 2 years to fix all this. What are we going to do about it? We started in October. The main focus of this performance and scalability projects is going to be 4 main areas. We're going to work on congestion control, which will allow us to increase the window size, which turns out to be the reason why that throughput is flat, because Tor uses what's called fixed window sizes. There's a cap on the throughput that's also dependent on latency. Proper congestion control will fix that. Load balancing, the ability to allocate client traffic to relays that have that spare capacity, improvements there will help as well, as will helping tune route latency and route throughput. Here's the specific nitty-gritty technical details if you want to try and chase some of this stuff down. Tor specification proposal 324 talks about doing round trip time based congestion control to provide dynamic windows. We'll be working on load balancing, improvements to SBWS, flash flow, and relatedly network health, which Georg will talk about in a few minutes. We're currently doing route latency parameter tuning with circuit build timeout, and we'll be looking into traffic splitting across multiple circuits. Now, most of these improvements are actually client and parameter based. Some will require exit upgrade, particularly congestion control, and all of these will require careful tuning and experimentation throughout the duration of this project, which Jim will talk about next. But we were able to prototype some of these ideas just to see how fast we could go with just the client through the client side improvements, and we were able to get 5 megabytes a second over this a full 6-hop Onion service circuit, downloading ReactOS, opening up the windows of the world. Thought that would be a good demo. 5 megabytes a second over a 6-hop Onion service, where normally you'd only see like 200 kilobytes to 500 kilobytes a second max. And this is just with the client side improvements. But if everybody did what we did in that prototype, it wouldn't really work. The network would become unbalanced. So proper fixes to these will have to provide fairness. We're going to have to tune them well, which Jim will talk about some of the tools we'll be using for that. And then with proper fixes, proper congestion control, proper tuned deployment, the network will reach a new equilibrium and we'll be able to actually use all of that spare network capacity, and clients will all have faster performance. We'll be able to make full use of our Tor network, which hopefully will make our hardworking relay volunteers very happy. So to talk about how we're going to be testing some of these improvements and how we do run these sorts of experiments, I'm going to hand over to Jim to talk about Tor network simulation.
All right, thanks. I'm going to be talking about some work on improving the shadow simulator. This is joint work between the Tor Project, Naval Research Lab, and Georgetown University, and is sponsored by the National Science Foundation. So a little background on the shadow simulator. This is a tool for simulating the Tor network. It works by running the real Tor software in an emulated environment where we intercept every system call into the operating system and return an emulated result. In particular, when the application tries to communicate with the network, we feed that through a model of the network that provides realistic latency, bandwidth, and packet loss, and so on that you would see in a real global Tor network. So this is useful for analyzing attacks against the Tor network and for analyzing performance, especially trade-offs of parameter tuning or alternative algorithms for scheduling or congestion control. While this tool is built with Tor in mind, it's actually applicable to any application network and has been used with Bitcoin in particular. So what have we been up to? A lot of the work this year has been working on a whole new architecture for how Shadow actually loads the emulated processes. Instead of loading everything into a single monolithic process, the new version loads each process into its own native process. This has a number of benefits. One is that you no longer need to recompile the software that you're trying to simulate. In fact, you don't need the source code at all. It also lets us use some other techniques for interposing syscalls. In particular, ptrace is a technique that lets us ensure that we catch every syscall, where before we could possibly miss some when using only LD preload, which is what Shadow 1.0 uses. This makes it possible to work on programs that use custom syscall wrappers, which includes Go programs, which previously didn't work in Shadow, and makes it easier to support adding new applications into the simulation, such as not just Tor, but a browser using Tor. The challenge with this new architecture is that there are some extra overheads from interprocess communication and context switching, and some initial results were quite a bit slower than the original Shadow. However, we've been working on optimizing this, in particular using techniques like spin locks and shared memory, and we've been able to close this gap quite a bit. In addition to the new architecture, we've been doing some improvements on kind of the Shadow code base itself. We've added an integration test suite that runs in GitHub on every proposed change. And it tests Shadow on a number of Linux distributions and compilers and configurations. And so this makes it much more likely that when you download and try to compile and run Shadow, it's just going to work right out of the box. We've also been doing a number of language migrations to more modern languages. Our scripting is now fully migrated from Python 2 to Python 3. Our configurations for the simulations are being migrated from XML to YAML. And new code for Shadow itself is being written in Rust instead of C, which gives us strong static type safety while still maintaining C's performance. So our goals for next year. We plan to do a release of Shadow 2.0 early next year with the new multi-process architecture. The next big change we're looking at is supporting running simulations across multiple physical machines rather than just one big machine, which should make it easier to scale large simulations. We're looking at adding some additional network modeling support, including better support for more accuracy for our TCP modeling, and support for modeling things such as routing. So you can use this today, and it's going to be a lot easier to use soon. So thank you. And next up is Georg on network health.
Yeah. Hello, everyone. So I'm going to talk a bit about network health, what we did in 2020, and what we're going to do in 2021. There are actually 3 points I want to highlight here. The first one is what actually goes into network health. Network health has not been a pretty popular topic in the past State of the Onion presentation, so I talk a bit about what this actually means. Then I talk a bit about our battery relay work, which we did this year and plan to do, and I cover the monitoring performance improvements Mike talked about. So network health is actually at the intersection of a part of Tor, actually several parts of Tor. if you are interested in the network health, in the health of the network, that means that you need some metrics first to get some baselines and get some improvements. And so it's obvious that the metrics team is involved here. Then there's a community aspect too. We need to talk about upcoming Tor changes to really operators coordinate this kind of stuff, and have to talk to directory authorities about upcoming changes and how we can improve the overall health of the network. And of course, there's a core Tor part involved here too, for instance, in the bandwidth scanners, which are important for load balancing in the Tor network. And finally, there's a lot to say about bad relay work, where we try to keep malicious relays out of the network to provide everyone a safe and secure stay while they are using Tor. So talking about bad relays, we realized this year that the overall work remains hard with our limited resources. We had several removals of large groups of malicious exit relays this year. And while doing so, we realized, not for the first time, but really this year, that that's an uphill battle which we have to change in the future to keep this sustainable. So we started to think about longer term plans, how we can change this arm race, and I'll talk a bit about this later. The other part Mike talked a bit about is network health involvement in the performance and scalability work. This is a central part, because if we want to see how our performance improves and how our overall scalability improves, we need some data and continuous monitoring of what we coded and what we deployed. So we have already scanners which do part of this, but we need to improve them and tune them to the new reality. And by the way, this should help as well with the bad relays work, because parts of the code bases are shared here. So this is actually a win-win situation. And we started as well on thinking about new tools that give us insight into the state of the Tor network, which will be important for the next year. So yeah, so the new and improved tools for performance and stability I already alluded to, and the other big point where we focus on next year will be progress on the bad relay situation. In particular, we thought about a change in the way that we try to get more traffic on relays, where we kind of know the operators and where we have some trust relationship involved. So provided we get some funding, which would be really helpful here, we think about hashing out what we mean by known. What does it mean for us when we say we know a relay operator, and what kind of trust relationships do we really want to have in the Tor network? And once we have this hashed out, we can actually start implementing this and make the overall security and safety of the Tor network better compared to what we have right now. So thanks for listening. Upcoming is Cecilia, who will be talking about the anti-censorship team.
Hi, I work on anti-censorship at Tor, and a lot of the stuff I'll be talking about is the hard work of many people, including my colleague Philip, other people at Tor, many of whom you've heard from today, and also a very large network of volunteers. So to start, I want to give a shout out to our volunteers, the people who run our anti-censorship infrastructure. We've added a lot of new bridges over the last year, including some default bridges, which are the first line of anti-censorship for many people who use Tor. These bridges ship with Tor browser, and so they reach tens of thousands of users and have very high reliability and throughput requirements. So we're very grateful for this capacity that our volunteer and community members have added to the network. Further, to ease the setup and running of bridges, we've improved our setup guides that we offer for a variety of different platforms. And also new, we've added instructions for deploying bridges using Docker. So if you're new to volunteering and you want to run a bridge, but you haven't yet, this is a very good place to start, and you can find all of our setup guides online. To get Tor browser into the hands of people in places where our download page is blocked, we also have a tool called Get Tor that distributes Tor browser binaries. And we've introduced a bunch of fixes to Get Tor over the last year. We've also added some new features, including allowing users to request Tor browser in specific locales. And we've also worked on a UX overhaul of Get Tor email and signature verification instructions to help users quickly and safely start using Tor browser. In some scenarios, our default bridges are blocked and users have to request additional bridges in order to connect to the Tor network. And the long-standing tool that we've had to do this is called BridgeDB. So our goal over the last year was not only to maintain and provide some fixes and enhance the usability of BridgeDB, but we also wanted to learn more about its effectiveness. And in order to do so, we extended our safe collection of metrics. And through this, we were able to learn a lot about how not only users interact with Tor with BridgeDB to get bridges, but also how sensors learn about and block our bridges. This additional information has been very useful in the beginning of designing and implementing a successor to BridgeDB that has a lot of new features and is generally designed to be more extensible. Some of the features we've started working on, and I'll talk about this again a little bit later, is to test bridges to make sure that we're not handing out ones that don't work. We're also working on features for bridge operators to make sure that they can check to see if their bridge is up and put their bridge back up if it's gone down. And we're also working on a feedback loop with third-party censorship measurement systems like UNI or some other academic ones to make sure that we're learning about the types of censorship that are happening and aware of which bridges are reachable in which places. As a more meta thing, we've also been working on automated monitoring of services. So making sure that RDSys or BridgeDB or GetTor itself is up and running. And over the last year, this has already helped us respond very quickly to outages and just improve our reliability in general. Moving on to pluggable transports, we've made a lot of progress on our new pluggable transport Snowflake, which uses very lightweight one-hop volunteer proxies to connect users with the Snowflake bridge and tunnels Tor traffic over a peer-to-peer WebRTC connection. When the year started, Snowflake wasn't in a very useful place, but now it provides a reasonably comfortable browsing experience. And this is in large part thanks to incorporating Turbo Tunnel. And also the influx of proxies that we've added. So over the last year, we've added the ability to run a Snowflake proxy easily using a web extension, and we've also been working on something available soon, an Android proxy app to allow users to volunteer bandwidth from their phone. You can see here the number of Snowflake proxies we currently have. We've been sitting pretty stably at around 6,000 proxies in the last 6 months, which is great. It's good to be in a stable position with a lot of capacity. And we're excited to see how much new capacity we can add in the next year. So some more things that we're excited about over the next year. One of the main usability enhancements that we are excited to work on is to make Tor browser smarter and reduce the amount of work that a user has to do in figuring out what types of censorship they face and how to circumvent it. We're also working on, with our new resource distribution system, a reputation-based system to reduce the ability of censors to discover and block all of our bridges and make it so that users are left with bridges that have remained kept secret from censors using reputation and looking at which bridges are blocked after which users find out about them. We're also hoping to make Snowflake more stable to increase the usability of it, its throughput, and its reliability. And we're excited about adding new distribution channels to GetTor. So in addition to email, we're hoping to expand into more commonly used instant messaging systems and distribute mobile versions of Tor browser in this way. So I'm going to end also in another call, and thank you to volunteers. There are a lot of different ways to volunteer for the anti-censorship team, and we love to have new volunteers join our community. Depending on what resources you have available or what you like to do, you can set up relays, bridges, and Snowflake. You can help us write code. Most of our projects are in Go and Python. And you can also help us stay aware of censorship events by documenting and analyzing it. And so the best way to get started is to join our IRC meetings, and I've left a link to our Rise Up pad as well. So thank you. Next up is Nick, who is going to talk about Core Tor.
Oh, hello. I didn't see you there. But in all likelihood, YouTube sees you there unless you're using some privacy-enhancing technologies on the internet. Right now, and for the last 20 years, I've been working on technologies to help people get private on the internet. And it's been a long and strange journey. This year especially, we've been hit hard by donation drop-offs due to the coronavirus pandemic. But we're slowly recovering, and we're going on with our mission to help Tor spread everywhere in space and time. To spread everywhere in space, we need to make sure that we provide privacy technologies for everybody in the whole world, that everyone can use on every device they've got. And to spread in time, we need to make sure that the things that we build outlast us, so that if I get hit by a bus or if I retire someday, we'll still be able to maintain all of the software that we've been working on. David has talked to you already about our HSV3 work, and Mike's talked to you a lot about our upcoming scalability stuff. But there are a few other things we've done this year that I think might be interesting. One thing is that we've done a whole lot of work to try to help IPv6 reliability for connecting to things on the internet via Tor that support IPv6, and for better support for IPv6 only clients. We've untangled a lot of old strange code that relays use to detect their own addresses in order to give a better experience for relay operators who want to support IPv6. We also designed a system called Walking Onions that I hope to be building over the next year or two with the rest of the team. And Walking Onions is meant to really lower the traffic overhead that a Tor client needs to have to connect to the network. Right now, Tor clients need to get a complete list of every single relay on the network. That's bad enough now, but if we imagine growing the network until it supports enough users to handle the whole world, then getting a complete list of all of those relays would be completely intractable. So with the Walking Onions design, we finally have a system and a plausible design for not having to do that anymore without any drop in security. Another cool effort we've been doing that, again, this is a future-looking thing, is something that I'm calling ARTI, A-R-T-I. It stands for a Rust Tor implementation. We're using the Rust programming language, which is much safer and much more productive than C, to do a nice, small, well-factored Tor client. And we hope it will be safer, easier to embed, and easier to maintain and hack on going forward than our existing work. Right now, exactly one person has used it successfully to connect to the Tor network, but I did manage to get it working with the Tor browser. I hope that by the end of the year, I'll get something that we can't actually recommend for secure use, but that does kind of work for other people besides me. And then, depending on our funding and resources, please donate, we might be able to work on already in the future. I hope that it will be the future of Tor development and the future of Tor clients in Rust. Who knows, maybe someday the future of relays. Also this year, and a shout out to our sysadmin team for this one, we have migrated from our old Track and GitHub setup, which was awful, to a shiny new GitLab installation that is great for clients and people who need to be working with Tor and working with our code. We usually get back to account creation requests within 24 hours, and it has been great for better responses to volunteer contributions. So if you're interested in hacking on any of our stuff, why not? Show up, make an account, give it a try. Okay, that's actually all I have to talk about for today, although I could talk for a couple more hours if they would let me. But next will come my colleague, Alexander Fare, who's going to talk about our work, making it easier to integrate Tor into other applications. Take it away.
Thank you very much, Nick. the last part of this section of the State of the Onion, I'm going to talk a little bit about the efforts we've had here in 2020 on integrating Tor into other applications. If you take a look at what the Tor application ecosystem looks like today, we have the Tor browser. It's a component that we're maintaining in the Tor project. You heard from Matt a lot about this and from Antonella. We have the Onion browser, which was initiated by Mike Tikas and is now maintained by some folks at the Guardian project. We have Tails OS, Onion Share. We have Briar, Ricochet, Coach, Ricochet Refresh, Secure Drop, Uni, and Brave. These applications all have different reasons for using Tor. Some of them are pure clients where they just need Tor to be able to access the Tor network and use the exit nodes and so on. Other of them are using the Onion services that you heard about from David, particularly for some of the nice properties that Onion service gives to applications, such as that you have the end-to-end encryption and the anonymity properties from Tor, and you have the authentication from the host names being the public key of the service. During today's State of the Onion, you will hear more about Ricochet Refresh and Secure Drop and Uniprobe a bit later. If we zoom in on the core component of a Tor stack, that is the Tor component itself, if we look at how Tor has evolved over time, Tor is a single binary today, which has a lot of different purposes built into it. First of all, it's a Tor client. That's what most people are using it for. You'll be using it to access the internet either via the exit nodes, or you will use the Onion services to stay inside the Tor network and browse securely through that. It's also a binary that provides the ability for you to host Onion services. So you can set it up together with a web server and so on and host things as an Onion service. Additionally, the binary is also a relay, and it's both a relay for a guard, middle, and exit, all three parts of the circuit that you're making. So this part has, of course, a component of Onion routing. It has the directory service. The directory service is used for clients to get an idea about the state of the network, to know about which nodes that are in the network. But additionally, the binary also supports things like being a directory or bridge authority. And today we only have 9 of these nodes in the network in total. So there's very few people who have a need to run this code inside of Tor. So one of the things that we have been working on here is to make some of these things optional. So today it's possible to build Tor without support for relays. And additionally, if you want to run it as a relay, you can also build Tor without support for directory or bridge authorities. This will hopefully remove some surface from people. Additionally, we've worked on making Tor easier to build as a library, so you can integrate it into your applications on both Android and on iOS, or on desktop applications that some people are using. So historically, most people have been integrating the applications with just the binary, but it's now possible to also interface with it via a very tiny API that we hope to work on in the future as well. As Matt talked about, in the Tor project, we've had a very, very big focus on mobile first. It has primarily been targeting the Android platform from Google, but here in 2020, we've worked with our friends at the Guardian project that you're going to hear more about later in the State of the Onion on enhancing Tor for the Apple's iOS platform. It comes from a very specific need that next slide will be about, but some of the things we've been doing here is working with them on integration issues, how they work with this new way of embedding Tor as a library. We've worked with them on a network extension, which is all about extracting TCP flows and handling DNS traffic and sending it through Tor, and especially also memory profiling. Some of the reasons that we're working on this here in 2020 is that Apple have deprecated the WebKit 1 API that exists on the iOS platform and are now only providing the WebKit 2 interface. Unfortunately, WebKit 2 does not provide access to the APIs that we need for transferring data through a proxy. So our best option here is this network extension system that we're working on right now. Unfortunately, the network extension has some limitations on the platform. For example, initially you could only use 6 megabytes of memory for it. Today you can use 15 megabytes. This is a very small amount of resources for doing what we want to do. And we need to have a little bit of a margin to be sure that we're safe in what we're doing. In the rest of 2020 and in 2021, we are going to continue focusing on helping people integrate Tor into their applications. We hope to see more people having good ideas where Tor makes a lot of sense to put into their software. We're going to continue working on the mobile part. We are mobile first after all. And we hope to also be investigating more VPN-like experiences in 2021. Thank you so much for listening. If you have any questions, feel free to ask on YouTube, and I will pass the mic back to our director, Isabella.
Thank you, Alex. And thank you, everybody, for sticking so far with our State of the Onion 2020. It's so exciting to see all the work that people have done in 2020 at the Tor Project, all the teams, but it's way more exciting to see what's coming up on 2021. I hope you all are enjoying so far. And I will spend some time right now sharing my screen to show you not only how our donation page works, but also some of the amazing gifts that you can get by contributing to the Tor Project. Like I said, this is a fundraising event, and right now we are on our year-end campaign, Use a Mask, Use Tor, Resist the Surveillance Pandemic. Just as a reminder, for every donation that we get, it will be matched by Friends of Tor. And you can see here counted already, like bumping, and it's been a great campaign so far. I want to show a little bit some of the ways you can donate. I want to show here all the cryptocurrencies that we are supporting at the Tor Project. If you are a cryptocurrency holder and you would like to make a donation, you can go to this page and find all the wallets that we have. Another thing I want to share with you is some of the amazing gifts that we are giving to people. We have here a special mask that we did just for this campaign. If you donate $50, you get this mask, and you also get a sticker. This year we have a special sticker. I'm not going to talk, it's a surprise, but just want to share with you a little bit of what we're giving. Another gift that we give for those who donate $75, it's a t-shirt of this campaign. And you can take a look here, close up on that t-shirt. Use a Mask, Use Tor. And you can, you're also going to be getting stickers with that. For folks who donate $500, we have a special hoodie that it's super cool. I love the design for this campaign. You can take a look at it. It's a close pull-up hoodie, and it has the logo of the campaign on the back and the Tor logo on the front. I also want to remind folks that for the stream only, if you donate $100 during the stream, you're going to get the t-shirt, but you're also going to get our poster from Molly Campbell that explains how Tor works. So let's see if I can load this poster here really quick so you can take a look on how cool it is. This is a poster that she made it for us, and it's a special gift that we only distribute from time to time on special occasions. So for everybody who donates $100 during the live stream, you can get this amazing poster, also a t-shirt. And again, I want to remind folks that you can do a one-time donation, but you can also do a monthly donation and become a defenders of privacy. And you will be receiving a special badge for that. And in case you want to donate more than $1,000, you become a champion of privacy, where we're going to be inviting you to a special webinar where our teams will be doing demos, and sometimes we have some interesting topics to share with you about what's going on Tor. I want to give another update about the donation page. In case you're coming to this page through our Onion address, you can only make donations through PayPal. Credit card will not work. And also, of course, you can still go to our cryptocurrency page. And right now, we have an issue with the BTC Pay, but we are fixing it. Just giving a heads up for those who might try that. And yes, this is, folks, a fundraising campaign from Tor. We are on our year-end fundraising campaign, and I hope you are enjoying the State of the Onion and all the updates so far from the Tor team. And now we're going to be entering our second part of the program, where we have invited different projects that are part of the Tor community. As you know, Tor is used by so many people and also promoted by so many projects around the world. But more than that, Tor works as an infrastructure for all the folks to build on the top of it. And there are so many cool projects that are, using the Tor technology to provide different services and trivial solutions to people. And we wanted to open space for those projects to also share their update. And I will get started by inviting Kushal from the Security Drop from the Freedom of the Press Foundation. Welcome, Kushal.
Thank you. I am Kushal Das. I'm a Python code developer and also a director at the Python Software Foundation. Along with this, I am a maintainer of the Secure Drop project. Secure Drop is an open source whistleblower platform which is being deployed over 70 news organizations and NGOs across the globe. It was originally created by late Aaron Swartz and now maintained by the Freedom of the Press Foundation. Freedom of the Press Foundation is another nonprofit based at USA where we protect, defend, and empower public interest journalism in the 21st century. Other than maintaining Secure Drop, we also have a digital security team who provides digital security training to the journalists at need and also provides newsroom security service. We then also maintain US Press Freedom Tracker website, which tracks any press freedom violation across USA. Now, before anything else, we're going to see where do we use all of these onion services. Secure Drop is a web application which gets deployed over 2 servers inside of each and every news orgs, and those servers connects to the Tor network. Now, a source can reach to any journalist of that news org via the source interface, which is the first onion service. Then, if they want to send some message, or they can also upload a file or any document to the same interface, the journalist can access a different onion service which is behind client authorization, so that only the journalist can view this interface, and they can download the encrypted form of the same files and messages, which can be later opened in an air-gapped computer. The sysadmins of these organizations can still reach these servers over Tor to the SSH system. And again, the system administrators will use the client authorization for these onion services. Now we're going to see what are the major work we did in 2020 and what we are excited about in 2021. We added the v3 onion address support, and as you can see in the screenshot, there are instances out there which are already using it. And after we did that, we also added deprecation warning to the journalists if their instance is still using v2 onion addresses, and it clearly tells them when we are going to disable this v2 onion address service. Later, with the help of the Tor project and also HTTPS everywhere rule set, we managed to add onion name support so that the sources can easily remember an address and they can still reach to the same onion service for the source interface. Outside of all this Secure Drop work, we also maintain Secure the News website, which tracks HTTPS and Tor onion service adaptation. And just like HTTPS, we hope in future this service will allow to more news orgs to adopt onion services easily. Next, what's coming up in 2021? As I mentioned earlier, we are going to disable v2 onion address support. We are going to do that in February 2021 so that it still provides some time before the Tor project itself disables v2 onion service. And along with this, we are also developing a new desktop application for the journalist, which runs on top of the Cubes OS and connects to the same onion service via along with client authorization, so that only journalists via this application can reach there. They can download all the encrypted material and view them within the single computer. This will reduce the time for their workflow to check any messages in a drastic way. Right now, this service is in beta, and even you can go and have a look at the source code on GitHub. But we hope in the coming year, more and more news orgs will actually start using this tool and adopt the newer technologies. If you have any questions, you can ask me on Twitter or in the chat or over email. And after me, I think we have Alison from the Library Freedom Project.
Thank you so much, Kushal. Thank you, everybody. I'm so happy to be here. Let me just take a moment to share my screen. So I'm excited to tell you today about my project, Library Freedom Project, which has been part of the Tor ecosystem for about 5 years. We are a community of practice for librarians who care very deeply about privacy, intellectual freedom, and the ways that those things intersect with our communities. You might be familiar with Library Freedom Project if you've been following Tor for a while. We have had a lot of really exciting things happen to us over the years. We have run Tor relays in libraries. We have installed Tor browser in many libraries. We had a really exciting thing happen in 2015 where one of our Tor relays was challenged by the Department of Homeland Security in the US, and we fought them and we won. And I'm happy to report to you that things in the Library Freedom Project community are going really well, even in 2020 in the midst of things being generally pretty terrible everywhere. So the relationship that we have to Tor is one of, we're teaching librarians and we're teaching local communities about privacy because we really think that having a grassroots approach to privacy education is a great way to combat all the kind of typical anti-privacy attitudes, people who think that they have nothing to hide or people who have heard that privacy tools are just for bad people. And also because librarians have a really strong commitment to privacy. It's one of our core values. So intellectual freedom and privacy, we see these things as very linked. You can't have intellectual freedom if you don't have privacy. So what Library Freedom Project does is teaches librarians about things like Tor and other privacy tools, and then also sort of the broader ecosystem of privacy and surveillance, things that are going on with privacy law and privacy policy, other kinds of surveillance technologies, the whole gamut of different things. And in this way, these librarians can teach their local communities about privacy. So as I said, we've been going since about 2015, actually a little bit before that, but we joined Tor Project in about 2015. And in the last couple of years, we have been working on something that I feel particularly excited about called Library Freedom Institute, which is a collaborative program with Library Freedom Project and New York University. It is a competitive program for librarians. It's totally free, but they have to compete to get into it. And it runs for 4 to 6 months. And basically, we cover a little bit of everything about the privacy problem. Each week, we have a different theme. We talk about privacy tools. We talk about the history of the internet. We talk about surveillance programs at the highest level all the way down to local levels. And then we work together to figure out ways to bring this information to our local communities. So in the last year, we've run 2 rounds of Library Freedom Institute for a total of about 50 librarians. So we have now a total of 100 librarians around the US working on these privacy issues, being part of Library Freedom. And the only reason that we're focused on the US is because of our funding, which is, I think, a really good reason why fundraising campaigns like this are so important, because small donor contributions are unrestricted, and projects like Tor and projects like Library Freedom really, really need that kind of unrestricted funds, because sometimes funders don't really allow you to do the same. So what we've been able to do is build this really important community of practice where the librarians work together on privacy issues and figure out ways that they can bring information to all different kinds of people. Another reason why we focus on libraries, not just because of the values and ethical commitment, but because of the kind of people that libraries serve. So many of the same people that we talk about a lot as being uniquely impacted by the loss of privacy are the same people who use libraries. So immigrants, people with politically dissident views, people of color, people who have been incarcerated, all sorts of people who have different marginalized identities. You can find them in libraries more often than you find like members of other populations. So what we do in Library Freedom Institute, like I said, we have this training program and they work together and we learn all sorts of different things. And one of the best ways that I can illustrate to you the work that we're doing together outside of the Institute, what they do after they graduate, is showing you some of the resources they made. So these are just some cropped images, but just to give you an idea. On the left is a vendor privacy audit that some of our librarians worked on. This is for any vendor that the library contracts with for databases, for other electronic resource services. And it's a really easy way to figure out how effective that vendor's privacy policies are, or their privacy practices, I should say. And so the actual audit goes much longer than this, and it has an assessment tool with it. It's really easy and clear for any librarian at any level to get a sense of how good or bad their vendor is on privacy. On the right is part of a facial recognition poster. This is more of a patron-facing poster, and it gives information about what facial surveillance is, why it's bad, why it violates our rights, where it's in use, and what you can do about it. So an example of kind of passive programming to give people a better sense of privacy and kind of impact culture more broadly. Another couple of crops of different resources the librarians have made. On the left is a handout about stalkerware. This one is actually translated into several languages. Again, really simple information, really brief about what stalkerware is, how it violates privacy, how you can know if you are impacted by it, and what you can do about it. And just something easy to print out and hand to patrons. And of course, in pandemic times, all this stuff is really easily shareable on social media. And then on the right is just an image from one of the teen privacy programs we've done. We made a zine series about privacy because we know that young people do care about their privacy. And these are all like in really cute, shareable, in a language that teenagers understand and relate to. So you can see, some of the images that we have on there. And then another resource that we just made is one about Amazon Ring, which is a surveillance doorbell. You may have seen this around your neighborhood. It's popping up all over the place. It is an always-on camera and microphone that reports activity directly to Amazon. And in the US, they have relationships with law enforcement. We hate this thing very much. So again, this is a really easy resource to share with members of the public. It's eye-catching, and it comes from librarians who are already trusted and are known to be people who care about your privacy. So Tor is a huge part of this project. We teach Tor in all of our institutes. We teach it in our member libraries, and we've been teaching it for years. People love it. And one more thing I want to show you is just an image of some of our librarians at a time when we used to get together. You can see Tor stickers on the table. They're all a lot of friendly, smiling faces. So again, just really kind of reimagining who privacy people are, where you can get information about privacy, why you might be interested in it. And so if you want to learn more about Library Freedom Project, you can go to libraryfreedom.org. Thank you so much for your time. And I would like to now introduce Richard, who's going to tell you about Ricochet Refresh.
Thank you, Allison. Let's see here. We good? There we go. All right. Hi, I'm Richard. I work with Blueprint for Free Speech, and we'll talk to you today about Ricochet Refresh. So first of all, what is Ricochet to begin with? So Ricochet is a kind of a decentralized instant messaging client built off of the Tor and Tor network, and specifically Tor hidden services. So basically how it works is that whenever you launch Ricochet, you create a Tor hidden service, and that gives you an onion URL looking identifier, which you can share with your friends offline. And then once they have that, they can launch their own instance of Ricochet, create their own hidden service, and put your name in, and you can do a little handshake. And this basically allows you to chat anonymously and no metadata, whatsoever. The only people who know about you and who you're talking to are the participants. But Ricochet's got some problems. First of all, it's very unmaintained. The last update was from like November 2016. It's reliant on the now deprecated V2 onion services, which others have already talked about previously. So what this basically means is that Ricochet will stop working sometime in 2021 once V2 is phased out and none of the Tor relays on the network understand what V2 is anymore. Initially, it's a bit minimal. You can have contacts and chat with them, which, granted, for some people is all you need. But we live in the 21st century now, and we like to do other things with our chat program sometimes. And for the nerds out there, it doesn't build reproducibly, which means you've got no real guarantee that that the binary that anybody publishes of Ricochet was built from the same source code that everybody else is building it from. And additionally, again, it's more nerd stuff. It can't be embedded. If I want to make some kind of, I don't know, Instagram clone or something that's based off of, anonymous chatting, you basically have to go and build all that yourself. Whereas it'd be great if you could just, import a library that facilitates, anonymous chat-like behavior and build on top of that. So enter Ricochet Refresh. Ricochet Refresh is being maintained by the Blueprint for Free Speech organization. It's an international org dedicated to the freedom of expression and supporting it by free software, research, outreach, and advocacy. You can find out more about them, well, us, they're paying me, it's pretty good, at blueprintforfreespeech.net. And they currently have up on their website, well, on Ricochet Refresh's website, an up-to-date version of Ricochet with V2 onions with various little tweaks and security updates, and also alpha builds for Ricochet Refresh. We'll get to in a minute. So Ricochet Refresh, the new alpha, has been updated to add support for V3 onion services. So this has all the previously mentioned advantages over V2 onion services. So once you create a Ricochet onion service, should be no way to kind of go through all the onion services and enumerate, yes, this is a Ricochet onion service, this is a Ricochet user, we should pay attention to this node. As it's V3, you get those nice super long V3 Ricochet handles, because the Ricochet handle is basically just an onion address without the trailing .onion and Ricochet prepended. It's not compatible with legacy Ricochet, because they're speaking two completely different languages, as it were. The protocols changed slightly, made it a bit more secure, based off some feedback we got from an audit a while back. But on top of that, it just uses V3 onions, which V2 doesn't know how to talk to. And as for using V3, it should be around for quite a long while, at least until V3 gets deprecated, which, hopefully there aren't any problems when we need to do that. Let's see. Speaking of feature set, we'll be adding a file transfer feature. Should be coming on our next beta build, either in December or January 2021. Well, December 2020 or January 2021. So you should be able to, talk to one of your clients or talk to one of your contacts and initiate a file transfer, so you can send, documents or cat pictures or whatever it is people send over instant messenger. We've made very good progress toward reproducible builds. We started off by forking the Tor browser build system and ripping out almost all of it, apart from the build tool chains and everything they need to build Tor, and added in configurations for building Ricochet Refresh and all of its dependencies. It's not yet reproducible, but the framework is there. We can at least cross-compile and have a standardized build environment rather than needing to mess around with that. We've made very good progress towards embeddability, especially this month. So other applications should not have to reinvent private instant messaging. If you want to add, Ricochet supports to, Pigeon or something, it should be relatively easy to do that. So there's been a good amount of work to get that working. Ricochet in its current form is basically a single monolithic Qt application. So I've been working on kind of extracting out all the Tor management and the Ricochet protocol and all of that, sticking it in its nice own little standalone library, which is just currently called libtigo for, I don't know why it's called Tigo, but you work with what you got. So once all of that is pulled apart and working, devs should just be able to basically import that library, use it with a nice little C API and build applications on top of it. And who knows what people can build on top of that. So yeah, alpha builds, we have them. We currently have built installers for Windows, which currently just installs a desktop, because why not? Linux x86 and x84 tar gzip archives, and a DMG for Mac OS 10.3 up, 10.3 and up. Wait, that's not right. 10.13 and up. Very different. They can be found on ricochetrefresh.net. Thanks. You can reach me. There's my email and my current vanity Ricochet Refresh v3 handle. You can find all the code of these various places. We've got the official repo and my current dev branches, or dev repos as it were. Next up, we've got Maria from Uni.
Thank you. Great. Well, hi, everyone. I'm really excited to be here. Thanks for having me. I work with the Open Observatory of Network Interference, commonly known as UNI, and we were born out of the Tor Project back in 2012. Since 2012, we have been developing free and open source software to enable you to independently investigate internet censorship all around the world. And since 2012, we have been openly publishing measurements collected by Uniprobe users in order to increase transparency of internet censorship and enable you to have access to data that can potentially serve as evidence of censorship. When Uni started off back in 2012, our app, our tool, Uniprobe, was in the beginning a command line tool. But over the years, we released a mobile app, which today is run by hundreds of thousands of users in literally almost every country around the world. And this year, we have been very excited because we had the opportunity to launch a new desktop app for Windows and Mac OS. Through the new Uniprobe desktop app, you can measure the blocking of websites, you can measure the blocking of popular instant messaging apps like WhatsApp, Facebook Messenger, and Telegram. You can measure the speed and performance of your network, and you can run a number of other different types of tests to measure different forms of network interference. We're also very excited to have new tests which are designed to check the reachability of popular circumvention tools. And this includes Tor. This year, we released a new Uniprobe Tor test, which measures the reachability of Tor directory authorities and Tor bridges, and more specifically, OBS4. And so as soon as you run the Uniprobe Tor test, you will immediately have access to the results inside your Uniprobe app, but your test results, your measurements, will also automatically be sent to our servers, processed, and openly published. And that way, by checking the measurements, you can learn where Tor works around the world and whether and how it is blocked in some places. The Uniprobe apps are powered by a measurement engine, and up until recently, our measurement engine was written in C++. This year, we deprecated our C++ measurement engine and rewrote it in Go. And this is really exciting because it makes the writing of new network measurement tests so much easier and so much faster. And apart from the new Tor and Siphon tests, we've also written a number of other new tests that we're excited about because we'll be shipping them as part of our apps over the next year. The types of tests that we decided to prioritize on was informed based on emergent censorship events that we came across around the world. Over the last years, we've frequently been seeing SNI-based blocking in many countries, and that is why we decided to prioritize the development of a new SNI blocking experiment. Similarly, other tests like DNS over TLS, we developed an experiment for that because we saw it blocked in places like Iran. But apart from the tests that have been developed by the Uni team, the fact that our measurement engine is in Go means that it also makes it so much easier for community members to contribute their own tests as well. And so over the last year, we've had many exciting contributions, such as a new test for measuring RiseUp VPN blocking. And we definitely encourage you as well to contribute any other tests that you would potentially like to see in the Uniprobe app and have users around the world run. Now, I think a very important landmark in the universe is that thanks to the great work of my colleague Federico, who literally rewrote our data processing pipeline, we are now in a position to analyze and publish UNI measurements collected from all around the world in literally real time. This means that as soon as you run an Uniprobe test anywhere around the world, you can expect your test results to be openly published within a matter of seconds or up to minutes. And the reason why we think this is very important and very exciting is because it literally enables the public, it enables you to independently monitor and investigate censorship events all around the world in real time. You can access UNI data through the UNI API, or we also have it hosted on S3, where you can download the raw data and perform your own analysis. But you can also refer to UNI Explorer, which provides a web platform and which has a powerful search tool through which you can filter through the measurements and access different types of charts. Based on UNI data, we have published a number of different research reports over the last year, and some of these are provided here in the slide. Unfortunately, what we've continued to see this year is that a lot of censorship events tend to be politically motivated. For example, in countries like Tanzania, Burundi, and Togo, we observed the blocking of social media during their 2020 elections. In countries like Belarus, we observed widespread internet censorship and even internet outages during protests. In countries like Iran, the Farsi edition of Wikipedia was temporarily blocked, and we also started to observe more and more SNI-based blocking and the blocking of DNS over TLS, as mentioned previously. But Iran is far from the only country where you can see SNI-based blocking. Amongst the various countries which adopt this technique, we also see Spain, which more recently started blocking a reproduction rights website through the use of SNI-based blocking. In other countries, such as Myanmar, what we saw was that a number of news websites which belong to ethnic minorities were recently blocked because they were considered to be fake news, and this was part of a government effort to tackle COVID-19 related disinformation. If you're curious to learn more about our research reports, please refer to the reports section of our website, where you can access the relevant UNI data and learn more details. I think one very exciting highlight from our community-related work was the Internet Measurement Village. This was a month-long event that we organized and hosted, which consisted of 18 presentations hosted almost every day on many different internet measurement projects, circumvention tool projects such as Tor, as well as different advocacy efforts against internet shutdowns. I definitely recommend that you check these out, and you can view these presentations through the UNI channel on YouTube. We're very excited about 2021 as we have a lot of new projects coming up, some of which are listed here. One thing we're very excited about is improving upon the Uniprobe Tor test to also bootstrap Tor and measure Meek. And another thing that we're very excited about is our new smart URL list system, which we've been working on over the last year. Through this smart URL list system, our goal is to improve website testing and to make the testing of websites more responsive to emergent censorship events. And then through this, we aim to sort of revamp UNI Explorer in order to provide more website-centric stats in order to provide more insight. We also plan to make Uniprobe available for Linux, and we also plan to release a new version of UniRun, which will make community-based coordination of censorship measurements much easier and faster and efficient. One of the things that we'll be experimenting with as well in 2021 is creating a browser-based censorship measurement tool to, again, enable rapid response to censorship events. These are some of the highlights from the Universe. If any of this excites you, please do get in touch. There's our contact email address here. Thank you very much. Please do get involved. And it is my pleasure to introduce Nathan from the Guardian Project.
All right. Hello, everyone. Glad to be bringing it home here for this great event. Thanks for your patience and time. Yeah, I'm Nathan Freitas with the Guardian Project, and known as Nate Freight. And I've been leading this effort for about 10 years now and working with Tor throughout that. So we're so glad to keep our collaboration going. And the mobile first attitude and direction of Tor obviously is very exciting for us. And we're glad to be on that mobile train. I want to really thank our team and our community Guardian Project. A big part of that is OK Thanks, who has really helped us pioneer work in sort of mobile-centric, human-centered design with users around the world. You know, when you talk about mobile first, you're really being much more inclusive and embracing all sorts of people in different situations, economically and with different connectivity, even different levels of electricity. So, you know, it's important to have experts in that to think through that and to work with people like Antonella on the Tor team. So thanks to all of that team at OK Thanks and the Guardian Project team, Benjamin, Mike, Hans, David, Carrie, Fabiola, Bim, Casey, Tiffany, and many more who work on our Tor-related efforts. So 3 things I'm going to talk about today. First, you heard from Alex earlier about Onion Browser and our struggles with iOS. So we'll be talking about that, but real progress too. Orbot continues, even with Tor Browser for Android, and we'll show the value that it offers there. And then building on the work that Cecilia spoke about and Philip in anti-censorship around pluggable transports, we've participated in that. And we'll talk about what that means on a mobile device. So apples and onions is kind of our phrase we talk about when we enter the Cupertino world. And first, a lot of our work at Guardian Project is deeply involved with activist groups, human rights groups, and efforts to combat censorship at many levels. And through our work with those communities, we're participated in the Worldwide Developers Against Apple Censorship Conference, which was simultaneous with the Apple Worldwide Developer Conference. And so the idea is to really get Apple to stop removing VPNs from the App Store. You know, they're this gatekeeper, as we've seen, and even more with some of the outages of even on the Mac with being able to run apps. It's a real problem. And so we've been really working on that angle on the advocacy level to make some ground there and work hand in hand with Tibetans, Uyghurs, Chinese activists, Hong Kong activists. And so, in fact, there was some real progress with Apple around a new human rights policy, but the work continues. And the hope really is that we can somehow make progress with allowing these devices not to be controlled, which binaries you can run to be controlled by the App Store. This matters because as much as we love working on Onion Browser, it is banned in places like China through the Chinese App Store. So then we have to encourage sideloading and all these other risky behaviors, which we don't like. And we would hate to see that kind of censorship expand to the world beyond China, even to Hong Kong. But that said, Onion Browser is better than ever. If you haven't been to onionbrowser.com, please go and see the beautiful site, and also links to video tutorials and information about how to best use Onion Browser on your iOS device. Mike Tigas has pioneered this work, but we've really expanded it to a much bigger and broader team. And this has included collaboration with Tor, as Alex mentioned, getting Tor to run within the constrained environment of iOS, figuring out how to run it in process instead of a separate binary, a separate executable, and also getting all of the various pluggable transport technology running within the limitations of iOS. And so a lot of excellent work there by TLA Designs, Benjamin, as well as UX design, as I mentioned, on how to make all of this smoothly work together within a WebKit environment. So part of this is considering sort of how you embed and integrate Tor inside of applications differently on iOS and even Android now. And so one of the things we realized is that if you want to start running OBS4 and Meek and Snowflake and multiple pluggable transports, you really can't include them as kind of separate bundles of code. You need to integrate these into kind of a single library. And so we've created a new IPT proxy library that incorporates the latest OBS4, Meek, and Snowflake into a single library that works both on iOS and Android. And that allows us to both manage the size of binaries and also just make them all work smoothly together inside of one application. So if you're interested in that, please check out the IPT proxy library from TLA Designs. And we're also dealing with this transition of UI WebView to WK WebView, which makes it more difficult to proxy traffic. And as Alex mentioned, we're working on how to do that because we cannot use our own browser engine like Gecko as you can. So, Apple really loves putting up sort of barricades to making safe and secure applications or making applications that want to do things that are interesting. We do believe that using the network extension methodology, we can get Tor running within the Apple architecture, but we've got a long way to go there. And we're really excited about some of the work that Nick and Alex and others are doing on making Tor more embeddable. So stay tuned for that. Work continues on Onion Browser. The other quite interesting thing we've learned is that with the ARM-based Macs, you'll be able to run apps like Onion Browser on a laptop, or a desktop. So the lines are starting to blur between mobile and desktop as well. So we'll be staying tuned to that. Orbot continues, of course, after 10 plus years. We're so glad for Tor Browser for Android to be out there, but Orbot still has its value and uses for non-browser-based applications of Tor on mobile devices. We have 1.5 million active users and nearly 20 million installs over those 11 years, sorry. And you can see the progress of the user interface from our early prototype to what we ship today. Some of the most exciting, important features on this are related to bridge distribution and being able to, within Orbot itself, actually get new bridges through a streamlined interface. This is also available in Onion Browser and really allows, through just entering a CAPTCHA code, to request and configure and deploy new bridges right within your app. This is really important for places where Tor is censored, and where users have challenges maybe using some of the other distribution methods. So thank you to the Moat team for that service. And beyond Orbot on Android and also on iOS again, we're really about pushing other apps to use Tor. So this year we launched with our partners at Open Archive the Save app, which is a very advanced kind of archiving media backup app that works with Amazon, the Internet Archive, any WebDAV host like Nextcloud, and also Dropbox, and it all can work over Tor through just a simple toggle. F-Droid, the leading open app store, kind of the antithesis to Apple, is amazing with the integrated Tor support and the ability to host app stores over onions. And most recently, there's been a lot of work in private DNS and ad blocking on devices. And so we see things like Rethink DNS, which is a firewall, kind of a little snitch app firewall and DNS privacy tool, have integrated proxying of traffic over SOCKS with the default setting to Orbot. And so users are really asking for more than just a VPN. They want full control of all traffic on their devices. And that includes routing traffic over Tor, but also firewall and DNS control. So we're excited about what Rethink is up to. And you heard a lot about onion services. Haven is a activist tool or any, sort of a private personal security tool. And you can access it like a remote IoT kind of camera over an onion service. So all the work that's being done with onion services is so key and important on mobile. And we really, see new types of applications for Tor beyond just web browsing. Of course, shout out to the Briar Project, who really has pioneered onion services on mobile. And we're excited for the Ricochet Refresh and Onion Share, for instance, which is another amazing project using onion services in different ways to come to mobile devices. It just makes sense. And we're really thrilled for the onion service work. Lastly, what we've seen increasingly as Tor has gotten more popular is more censorship of the Tor network itself. And so all of this work on Snowflake is so important. And what we really are excited about is bringing it to new kinds of devices. Orbot is very popular on Fire Sticks, Amazon Fire TVs, and Google just put out this Google TV $50 puck that runs Android. And so you can run Orbot on these devices, and you can run Snowflake as a proxy on these devices. And so, we're excited for the day that we can turn on 1 million Orbot users to become Snowflake proxies, for instance. So that's happening, and the IPT proxy library has support to be a Snowflake proxy now. So that's going to be a really great change in terms of capacity of bridges within the Tor network. And again, we're just building on the great work that the anti-censorship team is already doing. So, all right, well, thank you so much. And yeah, thanks to Tor for this opportunity, and the great work continues, and all of you for your support. Cheers.
Thank you, Nathan. And thank everybody for presenting, and for all the folks who are still watching and following this stream with us. I just want to give a shout out for all the projects that have presented here today. As you all know, privacy loves company. And I also want to invite you, if you can, collaborate with these projects to do so. If you have check out our blog about this live stream, State of the Onion, for each project, I have the URL here on screen. For each one of the projects from the community that presented today, we put a URL for the project website. And if you can also reach out to them and make a donation and collaborate with those projects, we would really appreciate that type of support. Like I said, all this work is extremely important. The millions ways that Tor can be reached and can be used, it depends on this collaboration. And all of these projects are also not-for-profit, also open source, and your collaboration is extremely important, as well as a collaboration to the Tor Project. So I also invite you to make a donation to the Tor Project. This is the last chance to make the $100 donation and to receive the poster from Molly Campbell explaining how Tor works. I showed to you how great that poster is. It's a special gift that we don't give away all the time. So it's your chance to get that together with a t-shirt of our year-end campaign. This stream, it was just it's very long but very short as well, right? Like so many presenters from the Tor team and also from our community. You have seen the amazing work our community team does, reaching out to users all around the world in the global south, as well as localizing and building documentation, the amazing collaboration between UX, the browser, and also our developers from the back end, bringing better experience for your users. We have been doing this for many years. As you all know, we don't do like the industry. We don't collect user data. We know our user problems by meeting our users face-to-face, like Antonella said, researching and talking with them and improving the experience for them. And there is more to come in 2021. As Anto said, and our anti-censorship said, Cecilia was explaining, we are improving the multiple ways that you can circumvent censorship against Tor. And the things that we build, the pluggable transports that we build, they also help other projects as well, other servers that might be censored, and they can use that circumvention to allow users from their products, from their servers, to bypass censorship against their servers, because all of this is open source, and we are a huge supporter of collaboration. And you also got a chance to see, the amazing work that we are cooking, what the onions that we're cooking here in the Tor kitchen, things that are yet to come in 2021, about the performance improvement, also about the different ways that we can implement tokens inside of our network. And the cool thing that Nick is working on, Arte, like a version of Tor and Rusty, this is an extreme step forward to ensure that the longevity of the project, right? Like, it's extremely important that we keep investing on that. And all of this depends on other tools, as you saw. Also, the simulator, the network simulator is important for us. We still have work for our metrics team as well that it didn't go into the program, but I want to give a shout out for the metrics team. And this is an extremely important thing that we wanted you all to understand, how all these projects are connected inside of Tor, and also how Tor is connected with all the community, all the other projects that are part of our ecosystem. We're not alone. Privacy loves company, and we love company as well. And being alone, we would not be able to do any of this. And because of that, I want to give another huge shout out for all the relay operators, all the bridge operators, all the volunteers that translate Tor, that translate our websites, all the people that help us, finding bugs, writing code. All of that support is extremely important for this project to exist. And I want to give you our shout out for being part of this community as well. And I want to thank you for being watching this stream. I know it's been long. We are almost on 2 hours time right now, but this is something that we were looking forward to share with our community. We, like I said, because of COVID-19, we didn't have a chance to be going out in events and sharing all these updates. So we decided to do this live stream and invite our friends to come and join and share updates on the project as well. All I can say here is thank you, thank you, thank you. Please support Tor. Please support this project. And thank you for being with us for this stream, for the State of the Union 2020. Looking forward for 2021 and looking forward for the more projects to come and looking forward to be doing this in a way that we are close to you, not on the internet, not against the internet, but it's also to be, it's nice to be close to people and get to meet people face to face. Thank you for your support. Thank you for sticking around. And in case your friend missed it, you can still share the YouTube link. This is going to be saved on your YouTube channel. Have a great day, everybody. Thank you for joining us. Bye.